In this example, we'll be reviewing the characteristics of a quadratic function. So the quadratic function I'm given here is 4x squared minus 6x plus 3. So a couple of things we'd like to look at before we get started would just be to maybe make a general sketch of this curve just on a set of axes I've drawn here. It doesn't have to be exact, and we don't need to be overly concerned about where we intercept or where our vertex or anything like that is. It's just to kind of give us an idea of the way this function is going to behave. So I can see that I got a y-intercept at 3, which I'll be asked for now in a minute. So I'm just going to sketch this something like this. Again, this may not be exact, it may not be the actual function, but it gives me a general idea of what I'm looking at. So the number of possible x-intercepts for any quadratic would be a maximum of 2. So that's all we're required to answer here. So we would say that this has 2 x-intercepts, or could have 2 x-intercepts. The y-intercept, again, is defined by the constant term. So that would be y equal to 3. I'm going to skip domain and range just for a moment here. For quadratics, they all have one turning point. And the end behavior, because this is a quadratic opening upward, it's going to be moving from Q2 back over to Q1. Now the reason I skipped domain and range just now is because for linear and cubic functions, we usually just tend to say that the domain and range are real. But when we've got a quadratic, because we've got that vertex, what happens is we end up with a bounded range, or some restriction we have to place on the range because there's values of y that we're not going to get. So the domain for this function will be the same as for a linear or a cubic, and it's just going to be real. But the range is going to require that we find the x and y coordinates of the vertex, and more specifically the y. So to do that, I'm going to use something we did earlier in the chapter, or you may have done earlier in the chapter, and also in Math 2201. And that's using this little formula, which is negative b over 2a. This would have given you your axis of symmetry in Math 2201, but it also gives you the x-coordinate of the vertex. So I need to put in a negative 6. So I'm going to do that. And 2 times a, which would be 8. So it's going to give me an x value at the vertex of 0.75. So now in order to find out what the range is going to be, I need to find what that function is when x is 0.75. So I need to take this and plug it into my original function for x. If I do that, I'm going to get a value of negative 5.25. So when I write the range for this function, I need to make sure that I state that y is going to be greater than or equal to, because it opens up, the y value at the vertex, which is 5.25, and also y is a real value.